Assalamualaikum. My name is IRFAN. Today, me and my team are going to present about heat stress and noise exposure level in a manufacturing plant by Chi Jae-kong. Workplaces are more than just space to complete tasks. Temperature and noise not only affect physical health but also cognitive function and emotional states, leading to variation in work performance. Heat stress, the cumulative heat impact from various factors, including environmental condition and the nature of work. Prolonged exposure to heat can lead to serious health issues like heat exhaustion and heat stroke, and it's crucial for industry to manage these risks. The wet bulb globe temperature (WGT) is a key tool in assessing heat stress. It considers air temperature, humidity, wind speed, and radiant heat. Excessive noise can lead to hearing impairment, increased stress level, and reduced concentration. The study highlights a growing concern with noise-induced hearing disorder in the manufacturing sector. The objective of this study is truly analyze heat and noise condition in a manufacturing plant, identifying potential risks and propose mitigation strategies to ensure a safe and productive workplace, and comparing local findings with global standards.
Greetings to Dr. Ziti. I wish you a pleasant day. I'm SUHAILAH binti RAMLI and I will be explaining about problem statement and methodology for this study. As for the problem statement, over 80% of reported incidents in Malaysia are related to occupational noise, and the manufacturing sector is the most affected, accounting for a significant increase in occupational noise-related hearing disorders. Worse yet, there is no comprehensive studies that analyze the simultaneous effects of heat and noise conditions in the manufacturing factories located in both hot and humid climates. Therefore, by measuring the various environmental factors in which contributed to the scene, the result can be compared to the previous studies, and relevant standards and guidelines can be used to determine if the conditions are within the acceptable ranges. Moving on to the methodology, there are 5 stages of steps taken by the research team involving actions like conduct pilot walkthrough survey, conduct field study, measure heat stress and noise level, calculate WBGT, ND and NEL, and lastly conduct workers' perception survey. The pilot walkthrough survey was carried out approximately a month prior to the actual assessment, and this step actually allowed the research team to identify the locations where the data was collected. After receiving permission from the factory management, the team then proceeded to carry out the field study on the manufacturing plant for pressure vessels. And this action encompassed both physical condition measurement and subjective evaluation, and it was carried out at the plant's 3 work sections, namely Section A, Section B, and Section C, from 9 a.m. until 5 p.m. Following the next crucial step, measurement of heat stress and noise level were both collected at 1-minute interval. As for the heat stress, a digital climate measuring instrument was utilized, and this instrument was linked to 3 sensor probes. Consequently, 3 thermal parameters including air temperature, relative humidity, and air velocity levels were acquired. And the research team also managed to follow the DOSH guidelines by positioning the instrument about 1.1 meter above the floor level. Meanwhile, the noise level inside the factory was recorded using a sound level meter which complied with the IEC Class 2 standard. And to ensure the accuracy, the meter was placed close to where the mechanical work was performed. Next, the calculation of WBGT, ND, and NEL were carried out in accordance with their specific formulas displayed on the slide. And in the final stage, the research team conducted another survey that was centered on the workers' perceptions of their thermal and noise environments. Unlike the first survey, this one has 4 sections, and the questions posed in the survey form were developed by referring to the DOSH itself.
Hi, I am AZUREEN meeting FARAEED, and I will discuss the result from the article that we did. In the result 1 show the use of fan-assisted natural ventilation for thermal comfort and fresh air in manufacturing section. It provides measurement of air temperature 26.9 to 35.7 Celsius. Relative humidity with level of range 44.3 to 83.6%. Air velocity recorded from 0.01 to 2.45 meter per second, and global temperature influenced by solar radiation at 3 workplaces ranging from 27.4 to 36.9 Celsius. The calculated WBGT index reflecting heat stress fall within the range of 25.2 to 29.8 Celsius with a mean value of 27.7 Celsius. Therefore, the highest mean WGBT value was obtained in section A. For the second result, the passage described the noise level in plant during working hour ranging from 40.4 to 111.4 dBA, with the highest level occurring in section A due to mechanical fitting works. The background noise remained below 45 dBA despite the difficulty in prediction noise level in such workplace. The result indicate that the noise level were generally below the 85 dBA threshold limit specified by DOSH for over 80% of the work time. The workplace is deemed acoustically safe for workers, with the calculated mean noise exposure level NEL of 74.1 dBA over an 8-hour exposure period, and the noise dose ND of worker ranging from 6.3 to 9.3%.
A survey involved 25 male skilled workers with full-time roles, generally in good health and performing light work. For safety, 64% of those in hot work wore protective gear, while others in various roles were lighter clothes. More than 65% found the workplace air temperature is acceptable, and 80% felt the humidity was comfortable. While most of the workers were content with the thermal environment, 76% of the welder felt it was warm, and 24% described it as hot. The radiant heat was perceived, but without the risk of contact of burns. In hot and humid regions without air conditioning, higher airflow rates are recommended for comfort, with ventilation fans helping maintain core body temperature. In a survey, 56% of workers in cotton covers and jackets felt the air was still in a warm environment. Others described it as warm at low speed, which is 90%, or in a hot environment, 25%. Similar response were observed in the workers in the lighter cloth, with 75% feeling low air movement. The survey's timing and location may have influenced workers' perception. In hot and humid regions without air conditioning, higher airflow rates are recommended for comfort, with ventilation fans helping maintain core body temperature. In a survey, 56% of workers in cotton covers and jackets felt the air was still in a warm environment. Others described it as warm at low speed, which is 90%, or in a hot environment, 25%. Similar response were observed in the workers in the lighter cloth, with 75% feeling low air movement. The survey's timing and location may have influenced workers' perception. In hot and humid regions without air conditioning, higher airflow rates are recommended for overall. Workers consider their workplace warm, with sensible air movement, moderately humid, and safe for heat-related injuries. During a noise perception survey, around 70% of workers felt their hearing was unaffected by workplace noise, and they did not experience dizziness. Most had not encountered noise loud enough to briefly muffle their hearing. Regarding industrial equipment use, less than 30% use such tool for hour, half an hour daily. Over 80% use hearing protector provided by company. Additionally, 75% feel their voice need to raise when communication with a colleague. Overall, workers consider their workplace warm, with sensible air, movement, moderately humid, and safe for heat-related injuries. During a noise perception survey, around 70% of workers felt their hearing was unaffected by workplace noise, and they did not experience dizziness. Most had not encountered noise loud enough to briefly muffle their hearing. Regarding industrial equipment use, less than 30% use such tool for hour, half an hour daily. Over 80% use hearing protector provided by company. Additionally, 75% feel their.
In the discussion one, the survey found that the most employees were comfortable with the temperature in their workplace. Regarding the perception of air movement, one reason for feeling low air movement could be the type of clothing worn by respondents. Additionally, working in area with a lot of equipment and material may have contributed to this perception. The use of stationary pedestal fan to create airflow mean that workers might feel a difference if they move around without adjusting the fan direction. For the second discussion, the workplace study is partially enclosed and natural ventilated, and the recommended threshold limit value for wet bulb globe temperature is 28 Celsius according to ISO 7243. Field measurements show that the higher WBGT reading 29.8 Celsius, 28.3 and 28.5 Celsius occur mainly during the lunch break when the outdoor high temperature was high. Despite this, the average WBGT value were below the recommended TLV, suggesting that workers were not exposed to excessively high temperature causing heat stress during their tasks. Compared to early study, the WBGT value in this workplace were much lower even during warm conditions. Section B survey participants note a warm surrounding temperature but still found it acceptable. This could be workers, especially those with extended exposure, tend to adapt to their work environment over time. The study did not consider personalized evaluation of heat stress level, but focused on analyzing field data based on selected location and mean score from heat stress survey question. Next, for the third discussion, the measured sound level indicate that the NEL did not beyond the allowed 85 dBA for an 8-hour period, as regulated by the 2019 Noise Exposure Regulation. The daily noise dose was also well below the limit of 100%. This was mainly because activity generating high noise occurred only briefly during the study. The loudest noise happened when hammering and heavy machinery were used simultaneously. But this occurred for a very short time. Machine and tool had less impact on the background noise, possibly due to large opening in the plant that dispersed the noise. The duration of worker using power tool and machinery was typically less than half an hour a day, as revealed by the survey. Most respondents did not report any noise-related issue or hearing impairment, likely attributed to the generally low noise level in the plant and use of personal auditory protectors during noisy work.
Let's proceed with mitigation strategies for heat stress. First, the manufacturing plant or company can implement engineering controls such as improved ventilation and cooling system to reduce heat stress in identified hotspots within the manufacturing plant. Next, they can also provide regular training sessions for employees on heat stress awareness, preventive measures, and the importance of hydration. Also, they can establish a proactive a monitoring system for heat stress, including regular assessments of environmental conditions and employee well-being. So, how can manufacturers reduce noise exposure? They can introduce engineering controls like noise barriers or enclosures to minimize noise levels at the source. Next, they can encourage the use of PPE such as earplugs or earmuffs for employees working in high noise areas, and they can rotate employees through different tasks to limit prolonged exposure to high noise levels. In the aspect of health and safety education of employees, they can conduct regular health and safety training programs to increase awareness among employees about the risks associated with heat stress and noise exposure. They can promote a culture of reporting and addressing concerns related to health and safety hazards. Last but not least, in terms of workplace design modification, they can consider redesigning the layout of the manufacturing plant to minimize heat-prone areas and noise-intensive zones. Also, they can ensure that break and rest areas are strategically located to provide relief from both heat and noise. In conclusion, this study systematically measured and analyzed a manufacturing plant's heat stress and noise levels. The field measure data showed that the heat stress and noise exposure levels were generally below the stipulated limits of the guidelines, which suggested that the locations under study were safe and comfortable for the workers. By addressing these issues through a combination of engineering controls, employee education, and workplace design modification, the organization can create a safer and more comfortable working environment. Ongoing monitoring and continuous improvement efforts will be essential to ensure sustained effectiveness in reducing heat stress and noise exposure levels. Putting these suggestions into practice should boost worker happiness and productivity in addition to improving the general health and safety of the workforce.